Most people believe the human body is fragile, that if you skip a meal, something immediately goes wrong. Energy crashes, muscle disappears, metabolism slows. But what if that belief is not only wrong? What if it's backwards? What if the human body was designed to function without constant food? Right now, somewhere in the world, someone is skipping a meal. They feel a slight hunger, maybe a little emptiness in the stomach. What they don't feel is the complex biological machinery quietly activating inside them. No alarms, no pain, no dramatic signal, just hormones shifting, fuel systems rerouting, genes switching expression, cells changing priorities. And within the next 24 hours, before starvation, before danger, before weakness, the body will make decisions that shape fat loss, muscle preservation, brain performance, hormone balance, inflammation, and long-term metabolic health. Most people will never experience this state, not because it's extreme, but because modern eating habits never allow the body to enter it. In this video, we are going to walk hour by hour through the first 24 hours without food. Not fasting myths, not influencer opinions, not ancient rituals, just physiology. Stay with me, because the most important changes happen before hunger even feels uncomfortable. If you want to understand your body instead of fearing it, if you want biology, not trends, subscribe to Health by Science. Because once you understand how your body actually works, you stop guessing, and you start making decisions that align with your biology. To understand what happens when you stop eating, we first need to understand what most people believe. Modern culture treats constant eating as normal. 3 meals, snacks in between, sugary drinks, late-night calories. Food is everywhere. And because of that, hunger has been reframed as danger. But biologically, hunger is not an emergency signal. It's a scheduling signal. For over 95% of human history, food was intermittent, unpredictable, seasonal. The human body evolved not in abundance, but in cycles. Eat, use, store, fast, adapt. When modern humans remove fasting entirely, they don't become safer. They become metabolically rigid. And rigidity, not fasting, is what leads to dysfunction. The moment you take your last bite, digestion does not stop. It accelerates into a coordinated shutdown and redistribution phase. Food in your stomach is broken down mechanically and chemically. Enzymes dismantle carbohydrates into glucose, proteins into amino acids, fats into fatty acids. These nutrients enter the bloodstream and trigger a controlled insulin response. Insulin is not a villain. It is a logistics hormone. Its role in this window is to move glucose into cells efficiently, refill liver and muscle glycogen, signal short-term abundance, prevent unnecessary fat release. Your liver acts like a battery, storing glucose as glycogen. Your muscles absorb glucose to replenish what was used earlier in the day. Nothing here is pathological. Nothing here is fat gain by default. This is metabolic housekeeping. Importantly, your body is still operating on external fuel. Energy levels are stable. Heart rate is normal. Brain glucose supply is uninterrupted. From the outside, nothing appears to be happening. But internally, insulin has a half-life. As nutrients clear the bloodstream, insulin begins to fall. Slowly, predictably, safely. And when insulin falls, it removes a biochemical lock. That lock has kept stored fat inaccessible. Within these first 2 hours, your body isn't burning fat yet, but it is preparing the system that will. This preparation phase is critical. It sets the conditions for every adaptation that follows. But as a manager, insulin's job is to move glucose into cells, signal abundance, temporarily pause fat release. Your liver stores glucose as glycogen. Your muscles replenish their reserves. Your body finishes accounting for incoming energy. At this stage, nothing feels different. No weakness, no fat burning. You are still running on external fuel. But hormonally, a countdown has begun. As nutrients clear the bloodstream, insulin begins to fall. And when insulin falls, another metabolic state prepares to emerge. Between 2 and 6 hours after eating, insulin levels continue their natural decline. This decline is not dangerous. It is expected. At this point, your body performs a metabolic check-in. Is more food arriving? Or do we switch strategies? When food does not arrive, glucagon rises. Glucagon is insulin's counter-regulatory partner. Its purpose is to maintain stability, not create stress. Under glucagon signal, the liver begins breaking down stored glycogen into glucose. Blood sugar remains tightly regulated. The brain remains fully fueled. This is why most people feel completely normal during this window. In fact, many report improved mental clarity, reduced brain fog, slight increase in focus. This is driven by small increases in adrenaline and noradrenaline. These hormones do not indicate panic. They indicate alert readiness. Evolutionarily, this is the state humans entered while searching for food. Not anxious, not weak, attentive, efficient. Your nervous system subtly shifts from passive consumption to active engagement. Metabolically, you are still glucose-powered, but the system is loosening its dependence on incoming calories. Flexibility is returning. But as alertness, this is the same state your ancestors entered while hunting. Focused, calm, efficient. Your body is not shutting down. It is preparing. Between 6 and 12 hours after your last meal, the body reaches a critical decision point. Liver glycogen, the stored carbohydrate that maintains blood sugar between meals, begins to decline significantly. This is not an emergency. This threshold exists by design. When glycogen drops, insulin falls further. And when insulin is low enough, fat cells finally receive an unambiguous message. Energy is needed. Release reserves. Triglycerides stored in fat tissue are broken down into free fatty acids. These fatty acids enter the bloodstream. Muscle cells increase their ability to burn fat. The liver begins converting some fatty acids into ketone bodies, an alternative fuel. Ketones are not toxic. They are not starvation byproducts. They are clean, efficient fuel molecules. Your brain, which requires constant energy, begins accepting ketones alongside glucose. This transition reduces reliance on blood sugar alone. This is metabolic flexibility, a capacity humans evolved to use frequently. Capacity modern lifestyles suppress. Your body's short-term glucose reserve begins to deplete. This is not starvation. It is transition. As glycogen drops, insulin falls further. Fat cells receive a signal they rarely get in modern life. Release energy. Stored triglycerides break down into free fatty acids. Muscles begin increasing fat oxidation. The liver starts converting some fatty acids into ketones. Your brain, which prefers glucose but adapts easily, begins using these ketones. This is metabolic flexibility. Most people have lost it. This is typically the window where hunger becomes noticeable. And this is where fear often replaces understanding. Hunger is commonly interpreted as danger. But biologically, hunger is largely predictive, not reflective. The hormone ghrelin rises in anticipation of habitual eating times. If you usually eat breakfast at 8 a.m., ghrelin rises near 8 a.m., regardless of energy status. If food does not arrive, ghrelin falls again. Hunger comes in waves, peaks, then it recedes. This is why hunger often disappears after 20 to 30 minutes if not immediately acted upon. It is not your body running out of fuel. It is your body checking a schedule. Understanding this distinction is critical, because fear-based eating prevents adaptation. And adaptation is what unlocks metabolic health. A hormone that follows patterns, not necessity. If you usually eat at 8 a.m., ghrelin rises at 8 a.m. If you skip the meal, ghrelin falls again. Hunger comes in waves, not a straight line. This is why hunger often disappears if you don't immediately respond to it. Your body is recalibrating. By 12 hours, insulin is low. Glucagon dominates. Fat mobilization accelerates. Free fatty acids supply muscles. Ketones supply the brain. Metabolic rate does not crash. In fact, it often increases slightly due to catecholamines. Muscle is preserved. Why? Because muscle is metabolically valuable. The body protects it. Protein breakdown remains low. Growth hormone increases. This is not breakdown. It is optimization. Cortisol often gets demonized. But cortisol is context dependent. During short-term fasting, cortisol rises slightly to maintain blood glucose, support alertness, preserve brain function. This is adaptive stress. Chronic cortisol is harmful. Acute cortisol is necessary. The difference matters. As fasting approaches 24 hours, the body changes priorities. Growth pauses. Repair accelerates. Autophagy increases. Damaged proteins are broken down. Dysfunctional components are recycled. Inflammatory signaling decreases. Insulin sensitivity improves. This is not detox culture. This is documented cellular biology. The body cleans house. You do not enter starvation. Starvation begins when fat reserves are exhausted. That takes weeks, not hours. You do not lose significant muscle. You do not permanently slow metabolism. Those outcomes come from chronic undereating, malnutrition, and stress, not controlled fasting. Constant eating keeps insulin elevated. Fat remains locked. Repair never activates. The body never practices flexibility. This leads to fatigue, insulin resistance, and metabolic confusion. Fasting is a tool. Not everyone should use it. Pregnant women, individuals with eating disorders, those with certain medical conditions. Biology is individual. The first 24 hours without food reveal something powerful. Your body is not weak. It is strategic. When you understand what it's responding to, you stop fearing hunger. You stop copying extremes. You start working with your biology. If this changed how you think about food, fasting, or health, subscribe to Health by Science. Like the video, share it with someone who believes skipping a meal is dangerous. In the next episode, we'll explore what happens after 24 hours, when adaptation goes even deeper. This is Health by Science. And this is how your body actually works.